Hi viewers, welcome to my channel. Today I am discussing the 2019 December NTANET question papers, artificial intelligence questions. Actually there are 8 AI questions in that question paper. So let's discuss one by one. Okay. So here the question is, consider the following learning algorithms. A, logistic regression, second one backpropagation, and third one linear regression. Which of the following option represents classification algorithm? Okay, and the options are shown here. First option A and B, then B and C, then A and C, then B and C, and the fourth option is A, B and C. Okay, actually the question is wrong here because it is not logistic regression, it is logistic regression and linear regression. Okay, so the question was wrong. So actually so here the question is to find the classification algorithm. Okay, the three learning algorithms are given and you have to find the classification algorithm. Okay, so actually the question is logistic regression, backpropagation and linear regression. Okay, so here we can identify what is a logistic regression. Okay, so logistic regression means it is a classification algorithm in machine learning. Okay, it is used when the value of the target variable is categorical in nature. Okay, categorical means mostly it is mostly used when the data in question has a binary output, that is 0 or 1, or whether it is present in one class or another. Okay, that way. Okay, so it is mainly used to check whether that data is present in one class or another. Okay, so this is a classification algorithm. Logistic regression is a classification learning algorithm. Okay, actually it is a supervised machine learning algorithm. Okay, so logistic regression is a classification algorithm. Okay, and the second option is backpropagation. So backpropagation means it is a supervised learning algorithm. Okay, backpropagation is a supervised learning algorithm and it is used to train a neural network. It is mainly used in neural network and it is used to train a neural network. Okay, it is also a classification algorithm. This backpropagation is a classification algorithm. Okay, and the third one is linear regression. Okay, so what is this linear regression? Linear regression is a machine learning algorithm based on supervised learning. Okay, so it is a regression algorithm. It is not a classification algorithm, it is a regression algorithm. Okay, so here the logistic regression is a classification algorithm and linear regression is a regression algorithm. Okay, so what is the difference between this classification and regression? So classification means you have to identify which category an observation belongs to. Okay, so the algorithms under the classification algorithm are this logistic regression. Okay, the first we have discussed. This is a classification algorithm and logistic regression is a classification algorithm and then the k nearest neighbors, support vector machines, kernel SVM, naive machines, decision tree classification, random forest classification. So these are some algorithms which are under classification algorithms. Okay, and the next category is regression. Okay, regression algorithm means it estimates the relationship between variables or correlation between variables. Okay, so it estimate the relationship between the variables. So the different types of algorithms under the regression are simple linear regression, multiple linear regression, polynomial regression, support vector regression, decision tree regression, random forest regression. Okay, then so this logistic regression and backpropagation are classification algorithms, and linear regression is a regression algorithm. Okay, so you have identified the difference between classification algorithm and regression algorithm. Is it? Now let's discuss what is a supervised learning and unsupervised learning. Okay, this is also coming under this section. Supervised learning means data which is used to train the algorithm, which is labeled with correct answers. Okay, that is the data in here. The data means the input data and also the output data are specified here. Okay, so we can easily train the data. Unsupervised data means the data there is no input, there is an input variable but not corresponding an output variable. Okay, so we have to create a model following the observation of the data. Okay, we have to study the data, and then we identify the structure and then we model. Okay, so that is called as unsupervised learning. Okay, no structure is given here. In supervised learning, the input and corresponding output is provided. Okay, but in unsupervised learning, there is no such criteria. There is no input. There will be input, but not there will be any output. Okay, so the algorithms coming under this category is supervised learning. The algorithms under supervised learning are linear and logistic regression. Okay, then multi-class classification, decision trees, support vector machines. These are under supervised learning. And unsupervised learning, k-means and a priori. These are the algorithms under unsupervised learning. Okay, so the logistic regression, backpropagation and linear regressions, these are coming under supervised learning algorithm. Almost majority algorithms will come under this supervised learning. Okay, so I hope you understand this question. So the classification algorithms are actually first one and second one. Okay, A and B. Okay, thank you. So let's discuss the second question in AI. Consider the following. That is first one, trapping at local maxima, reaching a plateau. Third one, traversal along the ridge. So the question is, which of the following option represents shortcoming of the hill climbing algorithm? Okay, the first option is A and B only, then A and C only, then B and C only, and the fourth option is A, B and C. Okay, so here the question is based on hill climbing algorithm. Okay, sorry. So what is this hill climbing algorithm? Hill climbing algorithm means it is moving some like it starts from a point and moves iteratively. Okay, so this algorithm stops when it reaches the peak value. Okay, moves incrementally or it moves incrementally. Okay, and that algorithm stops when it reaches a peak value. Okay, so after that the algorithm will decrement. Okay, the value will decrement. Okay, so the main drawback of this algorithm is that first one is local maxima. Local maxima. So what is local maxima? Local maxima means there is a maximum. There is a maximum point, that is So the main drawback of hill climbing algorithms are local maxima, plateau and ridges. Plateau and ridges. Okay, so local maxima means suppose the algorithm, suppose a hill is like this. Okay, so the algorithm will start from here, it reaches this point. Okay, so it reaches a peak, then there is a slope. Okay, so the algorithm assume that it reaches a peak point, and so the algorithm stop here, but actually there is a peak point here. Okay, but the algorithm doesn't identifies it. So that is called as local maxima problem. So it avoids, so we can avoid this problem by using backtracking. We can avoid this by using the technique called backtracking. Okay, and next problem is plateau. Plateau means the algorithm starts and at some point all the nearby points have same value, and then there is a peak. Okay, so these all points have same value. Okay, so that is called as a plateau. So to reach the higher point, we have to take a random value and then you can move. Okay, that is called as, that problem is called as plateau. All the nearby points have same value. So to avoid this, we have to take a random value and then jump. Okay, so this is called as plateau. And the next is ridges. Next problem is ridges. Ridges like this. That is, it is a subsection of local maxima problem. Okay, that is, there will be a peak and there is a slope, then there is a peak, then there is a slope, like this. Okay, so these are the problems in the hill climbing algorithm. And next is a different types of algorithms used in hill climbing algorithm. Okay, different kind of algorithms which are used in hill climbing algorithm. The first one is simplest hill climbing algorithm. Okay, simplest hill climbing algorithm means it start from a node. Okay, suppose its heuristic value is 25. Okay, it explore a node and then check whether its heuristic value is less than the current node. Okay, suppose this node's heuristic value is 30. Okay, so this heuristic value is greater than the current node. Okay, because 30 is greater than 25. Okay, so it is not a best value. Okay, so then it explores, then only it explores another node and then checks its heuristic value. Okay, suppose its heuristic value is 4. So this node is explored again. Got it? Suppose the first node's heuristic value is 3. Okay, so the node is explored here. The node will be explored. Okay, that is simplest hill climbing algorithm. And next is steepest ascent. Steepest ascent hill climbing algorithm. Steepest ascent hill climbing algorithm. It means it start from a node. Okay, and suppose its heuristic value is 20. Okay, it explores all the successor nodes. Okay, suppose this node has 4 successors, so it explore all the 4 nodes and then check the best heuristic value node. Okay, suppose this node's heuristic value is 15 and this node's heuristic value is 20 and or 25. Okay, and this node's heuristic value is 4 and this one is 10. Okay, so the best node is this one because its heuristic value is 4. Okay, so this node is explored. This node is explored again. So that is steepest ascent hill climbing algorithm. That is the second one. And the third one is stochastic hill climbing algorithm. Stochastic hill climbing algorithm means a random node is taken and check whether it can be the current node. Okay, if not, then it explore another node. Okay, so that is called stochastic hill climbing algorithm. And the next one is, the fourth one is shotgun hill climbing algorithm, or it is called as random retest hill climbing algorithm. Okay, so that means a node is that is a node explores another node. That is, that node is taken based upon that node is taken randomly. Okay, this node is taken randomly. And its heuristic value will be the best value. Okay, and that is stored, and then explores another node randomly. Okay, then explore another node randomly and checks the heuristic value. Okay, if it is better than the previous one, then this node's value is stored and then explores another node. Okay, and then checks heuristic value. Okay, if it is not the best, then the previous one is taken. If it is the best, then that value will be stored and that will be the heuristic value. Okay, that way. This is just like finding the largest element in an array. Okay, we put there will be a variable large. Okay, we assign a value to large, and then if there is one value greater than that large, then that will be the variable large. Okay, so that way. I hope you understand this topic. So here hill climbing, we discussed about what is hill climbing, what are the major disadvantages of hill climbing, disadvantages faced by hill climbing, and then the different types of hill climbing algorithm. Okay, so actually the question is we have to represent the shortcomings of hill climbing algorithm. Okay, so what are the shortcomings of hill climbing algorithm? This local maxima, reaching a plateau, and traversal along the ridge. Okay, these three are the disadvantages of hill climbing algorithm. So here the correct option is option 4. That is here. This is the correct answer. Okay, so I hope you understand today's topic. That is, we have discussed 2 questions based on AI. Okay, thank you.